Welcome to this video for the New York State Education Department standards around computer science and digital fluency. Here we're going to be looking at grades 2 and 3 in the concept area of computational thinking. At the bottom of your screen is the link out to this state ed website. Now, the second concept area we're going to be covering, the first being impacts of computing, this one is computational thinking. Please remember that you do not need to do these standards in any order. They're completely up to you and how you want to roll them out to your classroom. For computational thinking, there are four sub-concept areas. The first one is modeling and simulation. Here we're thinking about how we can represent data that we have in order to understand it or make predictions. As we shift from modeling and simulation, we move to data analysis and visualization. Here we're thinking about the ways that we can clean up the data we have, organize them, and cluster them together in order to have them be visualized and communicated in order to also draw conclusions and find some useful information within that data. As we move over to the right side of your screen, you'll see abstraction and decomposition is the third subconcept area. Here we're thinking about reducing complexity. So when you think about the steps you might do to complete a task, having your students think about the ones that are most important, or breaking down a task by decomposing that or breaking it down into smaller parts to make it simpler to understand. And then you may start to introduce some vocabulary around programming and debugging. And then finally, we have algorithms and programming, which is the largest of the four subconcept areas. Here, we're really thinking about what an algorithm is, which truly it's just a sequence of steps designed to accomplish a task. So, how you get dressed to go outside to the playground, or the steps you might use to solve a math problem, are going to fit within this algorithmic idea and could be something really useful in your classroom. On this page, you have the same resources that you had the last time. You have the state ed link. You have the Wakelet of more resources beyond this slide deck, and you have the activity books. I'm going to click anywhere on this page to take me out to the activity books. And since we're talking about grade bands 2-3, I'm going to click on this 2-3 book, click Read Now, and then I'm going to click the arrow to get to the table of contents. This time, we're going to go down to the computational thinking category. On your screen, you're going to see the concept area of computational thinking, the four sub-concept areas, and a video to help both you and your students understand what computational thinking means. So the first standard for modeling and simulation is create a model of an object or computational process in order to identify patterns, an essential element of a object or of the object or process. So here we're really thinking about representing and understanding, our patterns, our cycles of nature, tessellations. It could be models of the different buildings that you have in your hometown or the life cycles of different animals. So really, this is something you probably already do. You're just going to focus that lens to make sure that you're covering it from a computational thinking process. Again, you have some resources available to you to help you think about how you're going to use these standards in your classroom. And then we get to the next standard, which is under data analysis and visualization. Here we're going to identify and describe data collection tools from everyday life. The state ed examples talk about using things that we use in our daily life, like our Fitbits or digital thermometers or an accelerometer that might measure our distance. A great time to bring in your physical education department to help you do different resource or do different activities around this standard. Again, you have some resources for you. And then we'll move on to the next standard within modeling and simulation, which is present the same data in multiple visual formats in order to tell a story about the data. So here you're really thinking about how you can organize data, which can really be very helpful, especially as we move into third grade with the new science investigations. A lot of those investigations require students to understand data, which ties very nicely into your computational thinking strategies. Again, more resources. And then we move into abstraction and decomposition. Here we're talking about identifying multiple ways that the same problem can be decomposed into smaller parts. So really you're taking a problem and having your students think about different ways. Maybe it's the fastest way to get to the drinking fountain, or thinking about different ways that you walk from your classroom to the art room. It could be doing different activities like Mad Libs, or building comic strips and sorting activities. And then we're going to get into abstraction and decomposition, which is standard 5. Identify the essential details needed to perform a general task in different settings or situations. So here we can think about those essential tasks that you need in order to solve a problem. This can be done through origami, through different activities along those lines. For the next one in or algorithms and programming, here we're going to create two or more algorithms for the same task. So your students could choose two routes for a robot to go, or create how-to guides and think about all the different steps there, and then compare them to other students. You can have your students do different things with mazes. That can be super fun for your students to do for these standards. For standard 7, we're going to name, label key pieces of information in a set of instructions. But please note that whether each name label refers to a fixed or changed value. So here we're thinking about identifying the key things you need, like the lyrics of the song, or maybe the verse versus the chorus, and which things stay the same and which things are different. It could also be used during math when you're thinking about factors for tables and numbers for different activities you're doing there. Continuing on with algorithms and programming, we're identifying steps within a task that should be carried out under certain precise conditions. So here we're thinking about choreography maybe, or thinking about steps but that you need to continue. The next one under algorithms is identify and debug errors within an algorithm or programming that includes sequencing or repetition. Really good time to talk about the vocabulary here, make sure that our students understand what these words mean, and then we can have different things happen within our class to think about how we can fix mistakes or fix errors in our recording. The next one is the last one, which is develop and document a plan that outlines specific steps taken to complete a task. Here we could talk about storyboards. We could talk about creating steps to represent something as far as a routine that they do. So again, you're really taking a look at what you typically do for your routines, the way you use data, the way you organize different activities within your classroom.